story today. I just looked at next chapter, section 1 of chapter 7, that introduces with some new functions that called inverse functions. And they give us here the inverse functions, good morning, for various functions that we already learned in trigonometry class. For example, if you start to think about such function as a inverse to the function sine, how can we interpret that? For example, if you had a function favorite x squared, then the function f of x equal to x squared had inverse or the opposite operation to it, which is a square root of x. In other words, if you square some number, like say if you squared number 2, so function f brings you to 4, then the square root has to return you back the inverse function, which is applying square root to 4, and that gives us 2. That returns us back. Analogous to the function sine of x. So if I take, let's say, point pi over 2. So if I take pi over 2 and apply function sine to it, so you call it as function f of x, then I'm gonna get a sine of pi over 2, which is equal to number 1. Remember? You say, Alex, I already forgot all that. Well, you could look at the graph. This is a graph of function sine. And if you put pi over 2 for x, then y will be 1. In fact, probably it'd be more convenient not to use the graph for the function, but that favorite circle thing. So if I go for another copy of this textbook, Sylvan Recalculus, open that favorite last page, and we didn't see it for a while, so how could we, right? That's something that I want to double check. So let me go to the very end of this textbook. So I'm going to go to last pages and get that circular diagram. That's why I'm here trying to do that. So here's that circle that we, I hope, already familiar with a little bit. We'll get more familiar with it, no worry. So if you have angle pi over 2, which is 90 degrees, then its cosine is first coordinate or x coordinate, which is 0. And the sine will be a y coordinate, which is 1. So we got this value. Right, for 90 degrees angle, point is here, y coordinate of this point is 1 because it's point on this unit circle, on circle with radius 1. So the inverse function has to return us back. Where is this? Here. So if I want to find the inverse, then I need to start with 1 and go back to pi over 2, and that function is called arcsine, or sine inverse, like sine power of -1 of x. So if I apply that function, so if I take the arcsine of 1, then I have to get to pi over 2. So somehow I need to write this down, that inverse process, and the way to write is to use this sign with this -1, which actually stands for the inverse, not 1 over sine. It's a inverse. So the inverse function basically switches x and y axis, and that's what they show in this picture next to. So if you do this figure 3 observation, a reflection of function sine, which is put here in red, which actually continues, right? It's function sine. And if you try to reflect it through y is equal to x line, that switches x and y, so returns back y to x, then you're going to get the graph of that blue function. But notice if I continue, that will not be a function. Remember this vertical line test story, so there'll be lots of intersections with vertical line, and that's why we don't want that to happen, and that's why we restrict. See, that's the key part here. So we actually do not consider the whole reflection. We only restrict it on the little interval. This little interval is in between x equals to from plus to -1. So the x coordinates will be, for the blue graph, bounded, as well as y coordinates also bounded. So we just have only one piece of that big infinitely extending, right? So it could have been like that, but we only take one piece. And that's the key idea to realize, that actual graph of a inverse function, I can copy it here, is only one little piece, on contrary with the whole function sine. So it's just one little piece, because otherwise this is not going to be a function, and it's bounded in between minus and plus 1 for x, and minus pi over 2 and plus pi over 2 for y. What does this mean for us if we try to find various values? So I'm gonna go to the favorite circle and try to create a few problems where I can actually find them in the exercises section. So let's say if I try to take inverse sine, and then I can put any number for x, let's say 1/2. Notice that our possible values are always in between plus and -1, but since, let me clean this mess, our y coordinates of this points restricted, we're restricted in between minus and plus y over 2, so we can only get answers from this half of a circle, from that semicircle. Let's say if you are dealing with 1/2, here. Then for, oh, sorry, that's sine. That should be on the y-axis, right? 1/2 here on the y-axis, because that's a sine that we're working with. So what angle 1/2 corresponds to for the sine, for the second, for y coordinate? It's pi/6. So pi/6 is the result. So it goes backwards, because originally we used to, when started, deal with unit circle, we would say, okay, here's angle pi/6. What about sine of pi/6? Well, sine of pi/6 is 1/2. Okay, great. Pi/6, poor old pi/2. So now we're returning backwards. So we say, okay, what if we have 1/2? What will be angle that has a sine equal to 1/2? In other words, we are looking for angle. Right, different things. I don't know, I need to wake up, I guess. Angle that has sine equal whatever, 1/2 in this case. So what angle has sine equal to 1/2? Well, the angle is pi/6. And you say, but you could get angle here, right? No, angle we only find on that semicircle, because our function is restricted, because otherwise it's not going to be a function. That's the key idea. So only angles from that half of a circle will correspond to various values of sine that varies from -1 to +1. But angles can only be here. And I guess that's the key observation for finding various answers. So we just deal with interval from negative to positive pi/2. And that's, again, something that one needs to maybe get used to, think about over a weekend, get used to function arcsine, and if you will, I'm sure all the others, arc cosine, arc whatever, tangent, cotangent, will come out automatically. So I just want to go to the end of the section and do a few exercises here. Today's goal is to start to get used to function arcsine that gives us angles. So what it does, it always spits out the angle, whatever number in between of plus and -1 you're going to put in it, it will give you angle. So I can just be selective here, select only exercises that deal with arcsine. And looks like in exercise number 13, we have arcsine here. So I'm going to, I guess, clean some of this mess and take the exercise number 13 and decide what be arcsine of 0. So what angle has sine equal to 0? And well, I can look at that half of a unit circle and make a decision on that. So if I do exercise 13, that says find arcsine of 0. So the angle that has sine equal to 0 will be 0, because the angle 0 degrees, right? Like, for example, here we had pi/6. angle. So 0 degrees angle will have corresponding point on the unit circle, which is here, point with coordinates 0 for y and 1 for x. So I should put first number 1. First is x and then y, right? 1 for x and 0 for 1. And that's exactly the sine coordinate of angle equal to 0, because sine coordinate is my y coordinate, right? So it is right here. And that means that if I take arc sine, it's going to be also 0. But arc sine of 0 degrees, sorry, not 0 degrees, of 0 for the y coordinate returns me back 0 degrees angle, because that's angle. That's the whole point. The function gives us angle, such as sine of that angle is whatever we have here, whatever number we are applying arc sine. I say, Alex, could you just put this in a calculator? Could you just get your favorite scientific calculator and produce the answers? This could be one of the ways, but if angle is pi over 6, like in the previous little example, then it's definitely not going to give you pi over 6. It's going to give you some kind of decimal. So first of all, we can put this in terms of radians, because function arcsine deals with radian measure. That's how it's defined. So we get pi over 6. We don't get 30 degrees, even though one can say pi over 6 same as 30, but the calculator always gives you this radians. And now I need to get an arcsine. So how do I find it here? Well, it's in the function menu. So you go to the functions and you will find this arcsine here, right? And then I will just enter it. So arcsine, and now to get to 0, you go back to the main menu, because that's where the numbers are. So I have to click back main menu and then enter whatever number I have in mind, 0. So arcsine of 0 isn't it 0? But notice if I tried the previous one that was 1/2, right? We just found arcsine of 1/2. So if you put 1/2, definitely calculator is not going to give you pi over 6. You can see what calculator is going to give you. Some kind of decimal, and that decimal isn't it pi over 6. So if you divide pi by 6, you will actually get that decimal. But calculator is not designed in such a way. If you put it in terms of degrees, though, it will give you 30 degrees. So probably it makes more sense to use degree mode. Well, again, I'm giving you inside information because the textbook actually wants you not to use a calculator for this. But, I mean, if you know how to use technology, I think it's nothing but a plus, right? So I would say in terms of degrees, we know that pi over 6 corresponds to 30 degrees, then the calculator will give you right away numbers that we're used to. And then you can convert them to radians, because once again, these functions, they deal with radians. That's how they are designed. So they don't give you degrees. I say, well, Alex, what if I give you degrees? Well, I will understand. I'm not going to pick on that. But in general, if you plan to take calculus classes, then notice you never have any degrees. Like you have pi over 10 or 3 pi over 8. So all of these angles never going to be in terms of degrees. They will always give you radians. And that's how this whole chapter is going to work. But we know how to convert degrees to radians. So you can, this way you can use calculator. But I don't think it's very hard to just look at the half of a unit circle and get y coordinates. So how about another arcsine? I see number 19 here. So we need to take square root 3 over 2. Oh no, square root 2 over 2, but again, find the corresponding angle to it. And the angle that corresponds to square root 2 over 2 is 45. Remember? 45 degrees angle, or pi over 4. So when we have a square root 2 over 2, it's pi over 4. I say, Alex, how do you remember that? Indeed, I opened that circle for you here, right? So it's actually on it. You don't have to memorize pieces of this circle, but you could just, well, find square root 2 over 2 among y coordinates, because this is our arcsine. So we want to find angle that has its y coordinate or sine equal to square root 2 over 2. So it's pi over 4, of course, pi over 4 here. So arcsine is pi over 4. I say, I put in the calculator and gave me 45 degrees. Yes, but again, the answer will be always in terms of pi over 4, so some radian measure. And the reason is here, the graph. The graph gives us y coordinates in between negative and positive pi over 2, not in between minus 90 and plus 90 degrees. So radian measures. What else is interesting to notice about this arcsine function? Well, the fact that functions are inverses, if you remember in the college algebra, they say if you're applying the inverse function to the function itself, then the result has to be x. But not so fast, because the restriction. In other words, if you are going to be with angles in between minus pi over 2 and plus pi over 2, yes, this is going to work. But once you get outside, so if your angle happens to be bigger, let's say pi, well, then the result is not going to be pi. I say, what are you talking about? Well, let me find the values. Let's say number 38 exercise here deals with arcsine. Other problems here are all calculator exercises, by the way. They say use calculator, just plug in the calculator arcsine, and the calculator will give you some numbers. So I just shown you how to use it. So let me get something more interesting, because I'm sure calculator just enter it once and it's good for all of the exercises. So if I'm applying arcsine to the sine function, and the sine of pi over 10 was a negative, then the result will be exactly the same, negative pi over 10. The reason is that negative pi over 10 is in between of my values pi over 2, negative pi over 2. So negative pi over 10 is probably someplace here. if you take pi divided by 10. So it's fine, as long as it's on this semicircle. Because if your angle is not on this semicircle, then we're going to need to be careful. So let me find one which is not on this half, and I think it'd be with a sign, I think 41 will be one to watch out for. So let me do 41 and see how we can actually get our answer. So you also apply an inverse function in 41, inverse sine to the function sine of 9 pi over 8. And when you say, oh, they're inverses, so it should be 9 pi over 8. No. The reason is the angle that corresponds to 9 pi over 8 is actually not on that semicircle. 9 pi over 8 is going to be bigger than pi, bigger than 90 degrees. So it's somewhere here. I'll put another color. Let me actually clean this so I don't need that mess. Bunch of leftovers here. So 9 pi over 8 is more than pi. So it'll be pi is like that, right? And 9 pi over 8 is another pi over 8. So it'd be here. So what I need to do is to find the value for the function sine that corresponds to 9 pi over 8, but on this side of the circle. So if that was, this thing is kind of messing. So I'll put pi over 8 here, negative pi over 8. You see what happens? It's negative pi over 8 because we had pi over 8 added with pi, which is same as 8 pi over 8. That's how we got 9 of these pi's over 8s. We take 8, which is half rotation, and then one more. But I need to get the corresponding angle on my right half of semicircle. And the corresponding angle with the same y coordinate will be negative pi over 8. You see what's happening? I say, are you sure? Well, you can try it in terms of degrees if you want to. You can just put this, but of course it's not going to give you pi over 8, so I can get the calculator. I'll get some negative number of degrees. That's the point of it. So if I
Professor, let me ask you something. On this one, you couldn't go 8 pi over 8 and then pi over 8, and when you cancel it, it turns into 2 pi. Like you wouldn't use that method?
wait a second, not so fast. If you cancel it, I get 2 pi. If I cancel it, I get pi.
And then you add the pi that
Pi over 8.
Mm.
You don't have to cancel it. I don't want to cancel it. I actually want to expand it into 8 pi over 8. So you can see that 9 pi over 8 is actually has the key part for us, that extra pi over 8. And that's what I concerned with. And that's what helps me to actually get that picture.
Okay.
So anyways, that's good that you are looking at this and thinking about, that's actually the way to get used to it, because this is not obvious. This is not, I'm not gonna give you a quiz on this right now because that's bad idea. We need to see how the the key part is y coordinate. What angle on this right side will correspond to y coordinate that is given us by that 9 pi over 8, which is actually 8 of these pi's over 8 and one more. And that's, I guess, where it's coming from. So anyways, let me go to this arcsine thing once again. So maybe I can just go to the previous calculation so I don't have to re-enter arcsine and put this, what, arcsine of a sine, so just whatever they told me, pi over 8. Okay, pi divided by 8. And arcsine of a sine of 9 pi over 8. That's what the question is. 9 pi over 8. That gives you some kind of angle that I need to put in terms of degrees. So it's little degree. See, in radians, it gives you this negative whatever that happens to be pi over 8. So I can put this pi over 8 and you will see this pi over 8. But pi over 8 is positive, so it has to be negative, right? And that's what we just figured out. That's the same thing. And it's Alex, I have a hard time seeing it. Well, here it is. So you see that's indeed negative pi over 8. That's what we found is exactly arcsine of sine. But again, with the calculator, it's kind of hard to see it. Plus, if you try to turn this to degree mode, it's not going to give it to you. So that's why this is one of the, I guess, examples when we're out of the main. And that's worth to really think about. And I'm glad that you are, because this is really the way to get used to this arc functions. Let me clean this out, so I'm not going to give you the test. I'm going to give you another example instead. So if you have arcsine of sine, that's definitely something to watch out. But it turns out that when you're going sine of arcsine, then it's much simpler, like in the exercise, like number 45, for example. This is going to be just 1/4, because with the domain of function, arcsine is just fine. So the only issues happen when we have arcsine on the outside, because if you're dealing with just 1/4, then the result is going to be 1/4, or if you're dealing with the well, this one I should be careful because that one is undefined, because arcsine of -2 is not defined. Notice that if you look at the function arcsine again, and that was the graph that looks like that, it's only in between of minus and +1. So if somebody says, that's arcsine. Alex, what about -2? What if you take arcsine of -2? Well, then I cannot find it, because -2 is out of the main. I cannot really apply arcsine. -2 has to be, this is -1, so -2 is here, but there is no graph, so I can't find it. And again, in the calculator will also show you that. So if I go back to this calculator and try again to put, what was the question? Let me copy this so I can better see this. Number 50. So looks like I can use some room here. So exercise 50. That says take sine and apply it to arcsine of -2. Then the problem is with -2 because it's out of range, and I want to use a calculator to show this to you. So I go to functions. So I take function sine, apply it to arcsine, and then go back to main and try -2 here. And notice it is indeed undefined. So the message is you don't blindly say that if it's -2 here, then the result is -2, and that's it, because these are two inverse functions. It's not that simple because they are restricted. You see, their domains and the ranges are restricted, and that's the main reason why. And actually, I had to be careful. It's pi/2, and that's plus pi/2, and minus and plus 1 on x-axis, right? So we have a restriction. We cannot really plug -2 because -2 is out of the main, and I cannot really apply to function arcsine. So the problem is when I try to get a arcsine of -2, oh, I already wrote it here, then it's simply not gonna give me any result. And again, I can use a calculator to support that fact. So if I go back to functions and put arcsine, return back to -2, that's where the actual problem is. So undefined is on the arcsine part. That's where it is. So back to the page, to the exercise that I kind of brushed off, exercise 45. Everything was fine with it. I just want to write this down again, because there was no issue with the number in the parentheses. So if I try 45, that is dealing with a sine applied to arcsine of a quarter, well, then this will return me to the quarter, because if I start with function arcsine of 1/4, so 1/4 is, if I look at the graph someplace on the left, is 1/4. So I put it in the function arcsine, so I'm gonna get some kind of number here, and that's gonna be angle that arcsine equals to, and I don't really care what angle it is, because then I apply function sine, so it returns me back to my original 1/4, because the inverse function will return me back where I started to 1/4. So here is no problem. Again, because we were within the domain, we were between -1 and 1. We were not outside, because if we're outside of the domain, well, then there is nothing the function returns to us. So I guess that's pretty much all I wanted to discuss today, just to give you a flavor of this. I know this flavor is something that not obvious, so it's worth again that you look at this a little farther. And next Tuesday we're gonna continue this, so I don't give you a quiz on this. So next Tuesday I want to look at more problems with arcsine, but I guess the key part is to realize that calculator definitely is helpful in lots of cases, because when it doesn't work, when you're out of domain, then it just gives you undefined. So you need to then watch out and see what happens. And what happens usually, you are not on this semicircle, so you're someplace else, so you need to convert it to the angle which is on the semicircle. I just don't see many problems of this type here with arc science. I see more problems. There's some arc cosines. So next time I'm gonna take a look at arc cosines, and we'll go over the same exact ideas again. So I hope doing it again will make you feel more comfortable. So I'm going to stop at this stage. I'm going to send you a recording of this lecture as usual in a couple of hours or so, when it be available. And it'd be a good idea that you actually watch it over weekend before next Tuesday. It'd be very helpful. And that's the reason why I don't want to give you any quizzes right now. So just watch this recording, maybe do the same problems, and that'd be, I guess, the homework for next time. So I'm going to stop.